All right, hi guys. So this is Unit 1, Day 5 for Algebra 2 Honors, and I am Mrs. Rooker. Again, I am in classroom N2. If we are still doing the hybrid model and you're still in school right now, then feel free to come visit me if you ever need any help. And yeah, so let's get started. Today we are doing some more solving systems of equations. Unit 4 was also, or sorry, not Unit 4, Day 4 was also on systems of equations. And hopefully we talked about the 3 common methods of solving. So the 3 common methods are graphing, substitution, sorry, my pen's glitching out a little bit, substitution, and elimination. I kind of looked at the problems before I recorded this video, and just at first glance, they all look like ones that I would probably do elimination on, but that might be because I'm a little bit biased. I like elimination best, but I am going to try to do a little bit of both. So let's take a look at the first one. And by both, I mean both substitution and elimination, the 2 algebraic ways of solving, not by graphing. All right, so take a look at number 1. Oh, I just read the directions. It says to use elimination. And it looks like yesterday it said substitution. So we will be focusing on elimination today, not substitution. But I will review that substitution is where you're supposed to solve for one of the variables and then plug that expression into the other equation. But for elimination, what we need to do is get both equations into the same form. Usually that form is what we call standard form. Standard form looks like this. It's ax plus by equals c. So where a, b, and c are numbers. So if you look at number 1, both of these are already in standard form. The next step is to get opposite coefficients in front of either the x's or the y's. So what that means is we would need 5x and 2x to be opposite coefficients, meaning if one was 5, the other would have to be -5. Or we could do it in front of the y's. So positive y and -3y, we'd need to get those to be opposite coefficients. What I'm going to do, well, when I first teach this, I usually talk about thinking smarter, not harder. We have 2 options. We could get 5 and 2 to be the same. It's kind of like finding common denominators. You're trying to find the least common multiple that both of those go into. 5 and 2 both go into 10. So we could get this to be 10 and this one to be -10 or vice versa. But to do that, you would have to multiply both equations by something. So there's an easier thing to do, and that is to get the y's to be opposite coefficients. So here we have positive 1y and -3y. The least common multiple between 1 and 3 is 3, which means we can get them both to be 3. This one's already 3, or -3, but I can get this one to be 3 by just multiplying it by 3. Whatever you do to this, you have to do to the entire equation, though. So I'm going to multiply this entire equation by 3. When I multiply that, I get I get positive 15x. I get positive 3y. And then -30. I like that this one was a -3 and that one is a +3 because I want them to be opposite. The whole reason is because we want them to be able to eliminate. If they're opposite, they will eliminate each other. And then we'll just combine like terms. So 2x plus 15x is 17x. These two eliminate, which is the whole point of this method. And then 13 minus 30 is -17. Now we have an easy one-step equation. Divide both sides by 17. Those cancel. X is going to equal -1. Once you have the answer to one variable, you can plug back in to find the other variable. It doesn't matter which equation you plug into, but I pick the one that looks easiest. To me, this equation looks easiest. So 5 times -1 plus y equals -10. 5 times -1 is -5 plus y equals -10. And then to get rid of the -5, I add it to both sides. Y equals -10 plus 5 is -5. And then typically we write our answer as a coordinate point. So x always goes first, so -1 first and -5 second. And that's your final answer. We can always check our work when we solve systems of equations. So to check our work, we plug in. I'm going to kind of do this in my head a little bit. I'm not going to do a ton of writing since I'm out of room a little bit. But what I'm going to do is plug -1 in for the x. So we'll have 5 times -1, which is -5. Oops. -5. And then I'm plugging -5 in for the y. So plus -5 equals -10. -5 plus -5 equals -10. That is true. -5 and -5 combine to give you -10. So it works for the first equation. You also want to make sure it works for both equations, because working for just one equation means it could be on that line. Doesn't necessarily mean it's on both lines. So plug -1 in. 2 times -1 is -2. Plug -5 in. -3 times -5 is +15. -2 plus 15 is 13. So it works, which means that is the correct answer. All right, moving on. The first step when we're doing elimination, I'm actually going to write out the steps. First step is to get them both in standard form. Really, they just need to be in the same form, but standard form is the preferred form. So that's step 1. This one's in standard form. Ax plus by equals c. This one is almost in standard form. I have ax, but my by is over here, so I need to add that to the other side to move it to the other side. So this will be 2x, add 3y to the other side. Whoops. Equals the 14 will stay over here. So now they're both in standard form. Step 2 is to get opposite coefficients. Opposite, again, meaning if one's +2, the other one needs to be -2. All right, so I need to decide if it will be easiest to get 7 and 2 to be opposite coefficients or 2 and 3 to be opposite coefficients. Either one, you're going to have to multiply both equations by something, so I don't think there's any real wrong answer on this one. But I think I would prefer dealing with the 2 and the 3. They're just a little bit easier numbers to multiply by. So 2 and 3, the least common multiple between those two is 6. They can both be 6. So I'm going to multiply this one by 3, which will give us 21x plus 6y, and then 3 times negative 2 is negative 6. And then this one is going to have to multiply by 3. The issue here, sorry, not 3, 2. The issue here, though, is that this will also be 6y. 6y and 6y won't cancel out. One of them needs to be a negative. So I'm going to multiply the second one by a negative. It doesn't matter which one you multiply by a negative, but I like this one because I like my leading coefficients to be positive when I combine. Not something you really need to worry about, though. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. And then negative 2 times 14 is negative 28. All right, and then we're going to add straight down. That should eliminate one of the variables. 21 minus 4 is 17. These will cancel. And then negative 6 minus 28 is negative 34. Now we're left with a one-step equation. To get x by itself, we just divide by 17. X equals negative 2. Once you have the answer for x, plug back in to get y. Again, it doesn't matter which equation you plug into. I think I am just going to plug into this equation, but it doesn't matter which one. 2 times negative 2 equals 14 minus 3y. 2 times negative 2 is negative 4 equals 14 minus 3y. I'm going to subtract the 14 from both sides. So that'll be negative 18 equals negative 3y. Divide by negative 3, I get 6. So those are my two answers. I guess I could have flipped that around, sorry. And I'm going to write the two answers as a coordinate point. So negative 2, because the x always goes first, comma 6. And then we'll plug back in to check our answer. I forgot to keep writing my list of steps. So step 2 is get opposite coefficients, which we did. And then step 3 is to combine like terms. And this will eliminate one of the variables. Step 4 is to solve the remaining equation. So that's what we did here. We solved for the x. Step 5 will be to plug back in to one of the equations to solve for the remaining variable. Then you're going to write your answer as a point and then check your work. So checking our work is what we still have left to do. Plug negative 2 in here. 7 times negative 2 is negative 14. And then 2 times 6 is going to be 12. Negative 14 plus 12 is negative 2. So that works. Plug into the next one. 2 times negative 2 is negative 4. 14 minus 3 times 6 is 18. 14 minus 18 is negative 4. So that works as well. All right. All right, so right now, I was going to have you pause the video, but I'm not going to. Never mind. So let's move on to this one really quickly. They're already both in standard form, which is great. We need to get opposite coefficients. So either 3 and 9 need to be the same, but with opposite signs, or 4 and 12 need to be the same, but opposite signs. I'm just going to worry about the x's, not really look at the y's too much right now. I'm going to get 3 and 9 to just both be 9. So all I have to do is multiply this one by negative 3. The reason I'm doing negative is because that one's positive 9. This one needs to be negative, so they'll cancel. Negative 3 times 3 is negative 9. Negative 3 times negative 4 is positive 12. And then negative 3 times 18. Oh, it's been a little while since I've done math. I think that's 54. 3 times 18. Yeah, 54. So that'll be negative 54, which should look really interesting to you. Anytime both of these variables end up canceling out, which it looks like that's what's going to happen, you're either going to get one of two options, either all real numbers or no solution. And the way to determine that is to look at what you have left in the equation. So when we combine that, that's also 0. So we look at this right here. And we ask, is that true or false? That is a true statement. 0 is equal to itself. If it said 0 equals 7, that would be an issue. But that is a true statement, which means our answer is going to be, sorry, not all real numbers. I said all real numbers earlier, but it's not all real numbers. It's infinitely many solutions. You also might see it written as IMS. The reason it's infinitely many solutions and not all solutions goes back to understanding that the solution of a system is just where the two lines intersect. So a normal solution looks, I don't know, something like that. No solution would look something like this because they never cross, so that would be no solution. Parallel lines have no solution. Infinitely many solutions looks like this. We have a line, and then the other one ends up being that same line. That means any point on this line is a solution to that system. That's why there are an infinite amount of solutions. You wouldn't want to put all real numbers because all real numbers means this point out here is also a solution. But this point out here is not a solution to this line. So there is an infinite amount of solutions. Basically any point on this line would be a solution, but not all the points in the universe. So it's kind of a weird concept, but infinite doesn't necessarily mean all. And I know that's kind of a confusing topic, so definitely, this is definitely something to discuss when we are in class or on our Zoom meetings, depending on if we're on the hybrid model or distance learning still. All right, last one. So step 1 is to get them both in standard form. I'm going to do this kind of quickly. To get them both in standard form, I'm going to subtract the 5x to the other side. I'm going to leave the 6y where it is. I like the 6y on the left side, but I want to move this 37 over to the right. So I'm going to subtract the 37 over to the right. And then same deal on the next one. I want to get it into standard form. So I'm going to leave the 3x where it is. I'm going to subtract the 4y over. And now I'm going to add the 9 to the other side. That will combine with the 14, so that'll be 23. All right, I'm going to get the x's to cancel, so I'm going to multiply this one by 3 and this one by 5. That way they'll both be 15. So negative 15x. This will become 18. 18y. And then 3 times 37 is 111. And then the next one, multiply 3 times 5 is 15x. 5 times negative 4 is negative 20y. 20. And then 5 times 23 is 115. I'm going to have you guys finish this one on your own. So pause the video now, finish this problem, and then when you unpause, you'll see the answer. All right, so here is the correct solution, 5 comma negative 2. Remember, x always needs to go first in your coordinate point. All right, I know this was a little bit of a kind of jumbled video. Sorry about that. So make sure to come with questions to class if we have class, or Zoom meeting if we do not have class. All right, thanks guys.